Have you ever stopped to think about what you truly need to survive? Most of us would probably say food, water, air, and sunlight. For centuries, scientists believed sunlight was the foundation of nearly all life on Earth. Every forest, every coral reef, every animal, directly or indirectly, depends on the sun. But hidden nearly 1.5 miles beneath the ocean's surface lies a world that completely rewrote that story. A place where the sun has never shined. Yet life flourishes. Welcome to the extraordinary world of hydrothermal vents. Imagine descending through the ocean. The sunlight slowly fades, blue becomes black. The temperature drops, the pressure rises to hundreds of times what we experience at sea level. Eventually, you reach a landscape unlike anything on Earth. Towering black chimneys rise from the seafloor, releasing enormous clouds of mineral-rich water into the darkness. These are hydrothermal vents. Some of the water erupting from these vents exceeds 700 degrees Fahrenheit, yet it doesn't boil because of the crushing pressure deep beneath the sea. It looks like an alien world, and in many ways, it is. Hydrothermal vents begin where seawater seeps through cracks in Earth's crust. As the water travels deeper underground, it encounters magma, molten rock heated by Earth's interior. The water becomes superheated and dissolves minerals from the surrounding rocks. Eventually, that mineral-rich water is forced back through openings in the seafloor. When it meets the freezing ocean water, the dissolved minerals rapidly cool and solidify. Over time, they build towering chimney-like structures called black smokers. Some of these chimneys grow several stories tall, and they never stop changing. They collapse, they rebuild, they reshape the landscape continuously. At first glance, this environment should be impossible for life. There is no sunlight. The pressure is extreme. The temperatures can swing from near freezing to hundreds of degrees within just a few feet. Yet this is one of the richest ecosystems in the deep ocean. Giant tube worms, ghostly white crabs, vent shrimp, mussels, limpets, and strange bacteria crowd around these vents in astonishing numbers. But none of this life depends on sunlight. Instead, everything begins with microscopic bacteria. Most life on Earth relies on photosynthesis. Plants capture sunlight and convert it into energy. But here, the bacteria perform something called chemosynthesis. Instead of using light, they use chemicals. Hydrogen sulfide and other compounds pouring from the vents become the fuel for life. The bacteria transform these chemicals into energy. Those bacteria then become food for larger organisms. Entire food webs are built on chemistry instead of sunlight. It was one of the most important biological discoveries ever made. Scientists realized that life could exist in environments they had once believed were completely uninhabitable. The discovery of hydrothermal vents in 1977 shocked the scientific community. Before then, many researchers believed that life without sunlight simply wasn't possible. Hydrothermal vents proved otherwise. They forced scientists to rethink some of the most fundamental questions about biology. How did life begin? What conditions are truly necessary for living organisms? Could life exist somewhere beyond Earth? These questions suddenly became much more interesting. If life can survive here, could it survive elsewhere? Jupiter's moon Europa hides a vast ocean beneath its thick shell of ice. Saturn's moon Enceladus ejects enormous plumes of water into space, suggesting a hidden ocean below. Both worlds may contain rocky seafloors, internal heat, and chemical ingredients similar to those found around Earth's hydrothermal vents. If hydrothermal vents exist there, could alien ecosystems already be thriving beneath the ice? We don't know. But discoveries in Earth's deepest oceans have transformed how scientists search for life throughout our solar system. Sometimes, looking farther into space begins by looking deeper into our own planet. Hydrothermal vents remind us that life is often far more resilient than we imagine. They show us that even in complete darkness, surrounded by crushing pressure and fueled by chemistry instead of sunlight, life finds a way. Perhaps the greatest discoveries aren't always waiting among distant stars. Sometimes they're hidden beneath miles of water and places few humans have ever seen. The universe is full of mysteries, and this is just one of them.